Hi everyone, it's Mike Levin. Friday, April 22nd, 2016, around 7:30 p.m. And I'm here driving on the FDR at about the 116th Street exit, driving past Harlem on my way to Staten Island in order to pick up my daughter for the weekend. And hey, there's no time that's not appropriate for shooting a video, it seems. Anytime there's like downtime, there's that camera in your pocket, so pop it onto the GPS holder and we're in business. Today was an interesting day because I've taken my recent work, which was hitting against the Google Search Console API, previously Webmaster Tool API, as it is still known in its URLs, by the way. So it's going to continue to be Webmaster Tools to me until they go changing those API endpoints. And I did a very interesting set of work that hit against that 90-day window of data using different time range samples to kind of do a compressed time series and to get some directional indicators on whether things are going good or going bad. And it's work that I've been thinking about for a long time. In fact, this particular project was part of an About.com interview process that I had gone through a while back between 360i and Flying Point Digital. I wasn't quite the candidate they were looking for, but it was really interesting to discuss this project, and I finally got around to doing it. So Google has taken away tremendous amounts of information from us with not provided, part of secure search, where they cut off the keyword component of the data that's being sent to you every time you click on a result from Google. It used to be when someone visits you as a result of a Google search, you knew exactly what keyword they searched on. And even better, you could tell exactly what position it was in search results. And for whatever reason, Google decided to take that away as part of moving to HTTPS, or secure search. But they give it back in a very significant way through the Webmaster Tools API. And instead of having to come up with a list beforehand of all the keywords you're interested in, how you're doing on, and hitting against the search engines as if you're performing search in a process called position monitoring or SERP monitoring, or rank checking, you just connect formally to a Google data source, feed it some parameters, and you get back that same list, but many, many more keywords than you think to check on for yourself, because Google's sitting on top of all the data. And instead of seeing that you're in position, say in position 1 or 2 for a keyword, they'll tell you you're in average position 1.7 because they have a fairly large data sample and can give you very precise, averages. So that was a lot of fun. And as a follow-up to that project, I also connected, as of today, this is my brand new work, in the same script, I'm also connecting to the Google Analytics API, which is what you have when you're using Google Analytics on your own site. And instead of going in through the GA user interface and clicking around and setting dimensions and stuff and choosing your metrics, you can just, again, formulate a request, formulate a query, send it over, and get the results back, much like a spreadsheet. It really comes back in a JSON format that needs to be parsed, but it's all the same stuff. It's rows and columns, approximately. It's more object-oriented than rows and columns, but you can deconstruct it and drop it right into a spreadsheet. And OAuth, the authentication, the username and password stuff, is always a unique challenge. The sample scripts that Google gives is intended to be used on a machine that has a web browser. So you attempt to run a script, a web browser pops up. You answer a few questions, and suddenly you are authenticated. And that token lasts for a little bit of time, and until it expires, and then the process renews itself. But when you're running your script without a web browser in the picture, literally headless, maybe on a scheduler, a cron job, there's no way to do that web browser authentication. So what it does is it gives you a URL that you need to be sitting there the first time the script is run. You copy and paste that URL, somehow get it over to where there is a web browser, visit it, do the authentication there, you get a token back. That token you have to copy and paste back into the script as part of the interactive console session it starts, and then it stores onto the server's hard drive what you need for subsequent authentication so that you don't have to keep doing that all the time. And it does put what's called a refresh token there, so theoretically you should never have to do that copy and paste again. It's a one-time thing. So we'll see how that bears out. I do similar tricks. I actually hand-coded, server context authentication in Pipulate, and so far it's worked out really well. Once you have that refresh token, you're golden. So that's two data sources, Webmaster Tools and Google Analytics. Now I'm also fetching data from Amazon Redshift, which is a Postgres SQL database in the cloud, a giant cloud cluster SQL stuff. It's a lot like, SQL Server or Oracle or any of the other databases, but it uses a modified free and open source database called Postgres. There used to be one called Progress, and this seems kind of like a riff on that, but it's been around for a long time and now is much better known than Progress. It's Postgres with one S, officially PROGRESQL, but everyone just calls it Progress. And the connection to that is probably through a very secure VPN tunneling type thing, I would imagine, directly to our organization, because it's not the kind of thing that you should just be able to connect to willy-nilly, because it has a company's, very private and, as secure as they can make it, data. So once the company has that data feed, it then becomes available on the local internal network, and you use the equivalent of those old-fashioned Microsoft ODBC connections, but of course, no one does ODBC anymore, so it's JDBC. So you get a JDBC connection, you get the login credentials on your own network, so you have to be at the office or connected to your office, private network through virtual private networking through VPN. So I can't run that portion of this project on a generic cloud server unless I put all the same networking software on that cloud server instance so that it can connect back to our internal network, and that's just not worth doing. So instead of using one of my $1 a month Weibull Linux servers in the cloud, it's not quite $1 a month, but it's getting there. I spend about $8 a month for what is the equivalent of 5 CPUs or 5 servers in the cloud. It's not OpenStack. It uses another approach to virtualization, which allows them to do it slightly cheaper than the competition, and that's Weibull.com. But even though the project started out on that, I had to pull it back in to my laptop at the office that had the JDBC connection. So what the script is going to look like by the time this is done is hit Webmaster Tools, hit Google Analytics, and then hit the local SQL Server database. Not SQL Server in the Microsoft sense, but it is a SQL Server. And it's been 15 years since I've done real SQL work, at Scala Digital Signage, formerly Scala Multimedia, of once upon a time Amiga computer fame, one of the premier pieces of software for the Amiga that had made it in the post-Amiga world as digital signage. But for that company, I did a ton of SQL Server work in the Microsoft SQL Server sense, using Active Server Page and VB Script. And that was a long time ago, and even though SQL hasn't changed much in that time, all the ways of connecting to SQL has. And when you're using a language like Python, one of the free and open source languages, you have to choose a package, a connection package. Now, Python does ship with SQLite, so I believe there is some facility to connect directly to SQLite, probably through some built-in mapping, object mapping stuff, but I'm not 100% sure. Although what I do know is that I'm going directly to the third-party package known as SQL Alchemy. After doing my research, it turns out that SQL Alchemy is the probably second most used one out there, with the first being the one that's built into the Django framework. But I'm not interested in using that. I'm interested in using SQL Alchemy after doing all my research. And even once you make that decision, there's another decision to be made, choosing between the ORM, the Object Relational Mapping interface, which is a higher level abstraction than raw SQL, or using the ability to execute raw SQL against the database you're connecting to and deal with what comes back as, you know, a data grid that all the responsibility is on you to step through and interact with and build your own, I guess, API around. So I am going to do that the later. I'm going to be using SQL Alchemy Core because it's a whole bunch of very complex queries that I'm using to get the company data that I need, and I don't feel like abstracting it. I was working in SQL using a package called SQL Workbench /J, I guess, for Java, or more commonly just called Workbench. And it looks to me pretty much the equivalent of Query Analyzer that was built into the Microsoft SQL Server platform when I was using it around version 6.5 and 7.0. So Workbench is Query Analyzer. I'm very familiar with it and very comfortable in it, and have all my queries all designed out to get back exactly the tables I need, you know, pre-joined and all that stuff. So that will probably be my Monday work. I was hoping to do it today, but today I just got through the Google Analytics work. Yesterday I got through the work of, whenever I get one of these data grid result sets back, plugging it into Google Spreadsheets using the GSpread third-party API from GitHub. But unlike the linear sequential way I was doing it before, I started using the built-in Python data queue. And there's plenty of third-party data queues for when you're dealing with big data, lots of stuff that are back-ended by databases like Redis and stuff. But before I went making all those other dependencies, I decided to start experimenting with a data queue that was built into the Python, core packages. And it could allow me to switch to asynchronous behavior for updating Google Spreadsheets if I want. So basically, I could use multi-threading and stuff and fork one thing out in this direction to do all the data fetching and the API knitting together of what I need from different data sources, and then have a different task over here updating Google Spreadsheets with it, so that they can each go at their own pace, not inhibited or throttled by the speed at which each other want to go. But I'm not that fancy yet. I'm still using it in a fairly linear way, filling a queue, emptying a queue, filling a queue, emptying a queue. But it's a nice first step in case I want to go multi-threaded in the future. And it does help me decouple the script from Google Spreadsheets and GSpread. If I wanted it to go directly into Redis or Google Bigtable or some other database layer, I will no longer be so bound to Google Spreadsheets as I've been in the past. And naturally, I'm going to try and take my discoveries in this work and move it over to Pipulate and bring Pipulate up to the next generation and keep people from having to wait as it processes row by row by row, which was great for the first version of Pipulate, but it's clearly the biggest bottleneck, and if I can collect data much faster than that, I should be able to chunk it out and update in big chunky API calls instead of more granular row-by-row calls as I'm doing now. And I'll be documenting that whole process, and maybe it'll be Pipulate 2.0, maybe I'll do it in the very same repository, maybe I'll fork it, maybe I won't, I'm not exactly sure, but it will enhance the performance of Pipulate fairly significantly, and I believe in fairly short order, because I want this to be used all the time at Ziff Davis, where I currently work, for quality assurance and other checks where Selenium and other systems that are in use for testing are not necessary or appropriate due to their more heavyweight and very often scheduled nature. Whereas Pipulate is strong on ad hoc investigations. You think of something, you go out, you perform a crawl, you pull back 1,000 URLs that match a pattern, and then you go and you do some sort of lookup against each and then cross-reference it with another API source and build your own sort of index number to make evaluations. And this video is up to 17 minutes. I guess I'll wrap it up there, but you can sort of see the picture coming together. I am doing all the work that I've been thinking about doing for like the past 10 years, but have really not been able to, because I had to slip it all in personal time, which has been incredibly difficult because I had a kid in the middle of that, and of course I've been married for most of the time I've been in New York City. And now that kind of work is expected of me at my day job. And I'm entering a exciting new chapter in my professional life. Hopefully as much of this as possible will reach GitHub, so that the things I'm talking about in these videos and writing about in my online journal, I'll be able to cross-link it all together into a very smooth, integrated experience so people can follow along. And, thanks for sticking with me through this rather long video. Hope to see you again soon, and don't forget to subscribe.